Our first video of Unit 5 is on momentum and impulse. There are a lot of goals for this video, but they can basically be chunked into two groups. The first thing you're going to want to be able to do is to use the momentum formula to calculate momentum, and we'll talk about what that formula is. Once you're able to do that, you'll be able to rank objects from highest to lowest momentum, and you're going to be able to do some tricks to quantify how changes in mass and velocity affect momentum. The next thing that we're going to learn about, besides momentum, is going to be impulse. There's a formula to determine impulse, and I want you to be able to use that to calculate the change in momentum, and then to be able to explain what's going on too, especially to explain how changing the time of an impulse helps change the force of an impulse and how those are related. The best definition I've seen for momentum is simply mass in motion. So anything that's moving has momentum. And that definition also tells us the two key things that help determine an object's momentum. And that's an object's mass and an object's velocity. Some people like to think of momentum as how hard it is for an object to stop. So it's somewhat related to inertia, which we talked about in Unit 4. I want to tie together our bell work with this concept of momentum. Our bell work was, which one would hurt? Getting hit with a baseball moving at 90 miles an hour, or a baseball getting hit with a baseball moving at 50 miles an hour? And you guys correctly answered that it would hurt more to get hit by a baseball moving at 90 miles an hour. Why is this? Well, remember, the definition of momentum is mass in motion. So, a baseball moving at 90 miles an hour has more motion than a baseball moving at 50 miles an hour. Therefore, it has more momentum. Let's relate this to something that we learned before. If a baseball that has increased velocity has increased momentum, these two quantities have arrows pointing in the same direction, and that means that they are directly proportional. So, velocity and momentum are directly proportional. The more velocity you have, the more momentum an object will have. Our other bell work question asked if it would hurt more to get hit by a car moving at 50 miles an hour or a baseball moving at 50 miles an hour. And you guys correctly answered that it would hurt more to get hit by a car. Now, what's the main difference between a car and a baseball? Well, let's relate that to momentum. We said that momentum is mass in motion. Well, the motion or velocity of the baseball or the car are the same. They're both 50 miles an hour. But what the big difference is the big difference in mass. So, since a car has more mass, it has more momentum than a baseball. How can that relate to each other? Increased mass is an increase in momentum. So, we can say that mass and momentum are directly proportional. So an object that has more mass is going to have more momentum as long as it's moving. You can tie all of these concepts together mathematically with this formula, P equals mv, where P stands for momentum, M stands for mass, and V stands for velocity. Now let's take a minute to remember our units. A standard unit for mass is kilograms, and a standard unit for velocity is meters per second. Not meters per second squared, which was acceleration. So if you multiply these two together, you get kind of a funny unit for momentum, and that's kilograms times meters per second. For now, let's concentrate more on the formula than on the units. So looking at that formula, we can see that if an object is moving, it has momentum. That's because every object is going to have mass. So, when would an object have zero momentum? What do you think? Look at that formula. In order to get zero momentum, an object would have mass, but if its velocity was 0, any number times 0 equals 0. So an object would have 0 momentum when velocity equals 0 meters per second. Let's apply that a little bit. In this scenario, we have a car that's moving at 30 miles an hour, and we have a truck, a pimped out UPS truck, that's moving at 30 miles an hour. The question is, which has more momentum? Looking at our formula, P equals mv, the velocity of both is the same, but the mass is different. This tricked out UPS truck has more mass, so it's going to have more momentum. Now let's look at another scenario. Which has more momentum? This train that's moving at 0 miles per hour, or this marble that's moving at 1 mile per hour. Now just looking at it, the train has so much mass. But if the velocity equals 0, then the momentum of the train has to equal 0. So in this case, even though the marble has a very, very low mass, because it has a velocity of 1, it will have some momentum. Even though it's not that much, it's going to be greater than an object that's not moving. Remember, an object that's at rest has 0 momentum. The next concept that I want to get at is, how do you change momentum? Well, looking at the formula for momentum, in order to change momentum, you have to change mass or velocity, right? Now, if you look at this guy in his car, it would be really hard to change the mass of that guy or that car. So, how momentum is changed is by changing velocity. Now, to understand how we do this, we're going to have to go back and take a look at Newton's laws. Remember Newton's first law, where we said an object in motion will stay in motion at a constant velocity unless something happens. Do you remember what that something was? That's right, an object stays in motion at a constant velocity unless it's acted on by an outside force. So, how do you think you change momentum? Well, we said you'd have to change the velocity, and in order to change the velocity, there has to be an outside force. So how do you change momentum? You have an outside force. But depending on the type of the outside force, you can change momentum in different ways. Let me explain. An object in motion tends to stay in motion because of its inertia, and its inertia is related to its momentum. So, that object is going to be kind of hard to stop. And this is really easy to imagine. Think about a time where you were in a car, and you're coming up to a place where you have to stop. You can stop in different ways. You can stop that car's momentum in different ways. You can slam on the brakes really, really hard, or you can ease on the brakes. What are you doing when you stop those different ways? You're changing the amount of force on the car, and then also you're changing the time that the force acts. So in order to stop an object's momentum, you can apply a great amount of force for a short time, or a small amount of force for a longer time. And this is the essence of changing momentum in different ways, which is also called an impulse. So here's our second key word of the day, impulse. How you define impulse with words is a change in momentum. And how you can define impulse with a formula is just force times time. So impulse equals F times T, where F equals force, T equals time, and force is in newtons, and time is in seconds, so the units for impulse would be newtons times seconds. Now with both of these formulas, P equals mv and impulse equals ft, it's going to be more important to understand the concept than necessarily plugging and chugging and calculating. Here's that formula again. We said that impulse equals force times time, but we said with words that you can define impulse as a change in momentum. So technically, you could change this definition or this formula to the following. Force times time equals change in momentum. Now, us relating these two concepts, impulse and change in momentum, is going to become very important as we move forward. But for now, let's consider a closing example. Here's something a little more dramatic than stopping your car at a stop sign. Let's say your car was going to collide with something. That something could be a brick wall or a haystack. Which would you prefer colliding with? I know I'd prefer colliding with a haystack. Now what happens with each is, since the force to stop momentum, the impulse, happens over such a short time, to stop this car, that's going to mean a very big force. So if you're inside of that car, its momentum is going to completely stop, but you're going to feel a very big force. Now if you ran your car into something like a haystack, what's happening is you're changing that momentum, you're applying that impulse over a longer time. Now you're still changing the velocity of the car to however fast you're going to zero, but since it's taking more time, then there's a smaller force. And this is why, if you crashed your car into something like a haystack, you'd probably survive it. But if you crashed your car into something like a brick wall, you'd likely get really injured. So, I hope you feel comfortable with writing the formulas for momentum and impulse, and using them and being able to discuss and use these words like a good young physicist.